These Chapter 3 notes are meant to be covered in class. They're posted for people who are absent the day that we go over them, or for students who entered the class late and need to get caught up. Here we have a contingency table with two categorical variables, eye color and sex. There are 64 people in our table, 32 each of males and females, 10 with blue eyes, 36 with brown eyes, 18 with green, hazel, other eyes. The wording of these questions is very important, so make sure you pay careful attention to them. All right, what percent of females are brown eyed? Okay, so in this case, we're only looking at the 32 students who are female. Of those 32 females, 16 have brown eyes, so 16 over 32, which is 50%. You can write it as a decimal or a percentage. What percent of brown-eyed students are female? Okay, did what's called reverse the conditioning. So now we have 36 brown-eyed students. 16 of them are female. So 16 out of 36, switch it to a decimal or a percentage. I don't know what it is off the top of my head, but let's see. Divide them both by 4, so it looks like it's 4/9. What percentage of students are brown-eyed females? So now it's saying what percent of students. So we're talking about all 64 students. Okay, of those 64 students, 16 are brown-eyed females. 16 out of 64, that's 25%. What's the distribution of eye color? Eye color we see across the top here, which means we want to look at these numbers that correspond with those eye colors. And we're just going to take each of those numbers and put them over the total number of students. So 10 over 64, switch it to a percentage, 36 over 64, 18 over 64. So the distribution, 64. Distribution of eye colors would be 15.6% blue, 56.3% brown, 28.1% other. What's the conditional distribution of eye color for the males? In the conditional distribution, it's giving us some kind of condition. So in this case, the condition is that we only want to look at the male students. So instead of looking at all 64 students, we're only looking at the 32 male students. And then we do the same thing we did in the last problem. 6 over 32, 20 over 32, 6 over 32. Switch them to percentages, and that's our conditional distribution. Based on the previous answers, does it seem that sex and eye color are independent? So when two variables are independent, it means that they're not affecting each other. Okay, in other words, that males and females would have the same distribution of eye colors. It doesn't matter if you're a male or a female. You're just as likely to have blue eyes, brown eyes, green, hazel, other eyes. In other words, all those percentages would be the same for males, females, and the total. Okay, if we look back at those previous two slides, we saw some differences. Okay, and the question always becomes is how much is too much, all right? What's the same in this class and what's different? And as we get further into the course, it's a little easier to define that. But based on those two previous slides, the biggest difference we saw is in green, hazel, and other. 28.1% of the total number of students had green or other eyes versus only 18.8% of males. We're going to call those two numbers different and say that these are not independent. There's an association between your sex and the color eyes you have.